Okay, for number 3 in the free response, we need to find the sum of the series. So our series is from 1 to infinity, e to the 1 over n minus e to the 1 over n plus 2. And now, right off the bat, you should recognize that this looks like a telescoping series. Now, whenever you have two things that are subtracted, that's really what should ring that bell in your mind, because if you think about it, pretty much all the series that you do other sorts of tests on are not two separate things that are subtracted from each other. So just because you have the subtraction, immediately you should think, okay, that's probably telescoping. The other thing that lets you know exactly that it's telescoping is that these two terms are the exact same thing with n replaced by n plus something else. In this case, it's n plus 2, but it could have easily been n plus 1. In any case, these two are the same thing. They're just shifted. So this, whatever this is the same thing 2 terms later. So this is definitely telling you that this is telescoping. So whenever you have a telescoping series, the separation between the two terms is going to tell you how many are not going to cancel. So remember, for telescoping series, nearly every term is going to cancel. But you're going to have a few that don't. In this case, we're going to have 2 that don't cancel at the front and 2 that don't cancel at the back. So the easiest way to show this is, let's write out the first couple of terms. First term, when n equals 1, we get e minus e to the 1/3 by plugging in 1 there. Next term, when n equals 2, e to the 1/2 minus e to the 1/4. The third term, we have e to the 1/3 minus e to the 1/5. And that's where we can stop, because now it's easy to see what's going to happen. We have a negative 1/3, or negative e to the 1/3, positive e to the 1/3. Those are going to cancel out. And similarly, all the terms are going to cancel out except for, and this is what I said before, there's going to be 2 that don't, e and e to the 1/2. So these are kept. Everything else is going to start canceling out. Now let's see what happens now down at the tail end of the series as we get closer to our term just being n. For the n minus 1th term, we have e to the 1 over n minus 1 minus e to the 1 over n plus 1. And finally, the very last term, the nth term, is going to be exactly what it says here. So which 2 are going to get kept out of this? It's going to be these last 2. Because if you think about it, the term before this would have had an minus e to the 1 over n. And it would have canceled out with this one. And every subsequent one would cancel. So the first 2 terms, let me rephrase that. The first parts of the first 2 terms and the second parts of the second 2 terms. That's what we're going to keep. So you know it's 2 of each because there was a 2 separation between the terms. So the last thing we need to figure out is, this series is going to infinity. So these last 2 terms that are going to stay there, we need to take their limits as n goes to infinity and see what happens. So essentially, this sum of this series reduced down to e plus e to the 1/2 minus e to the 1 over n plus 1 minus e to the 1 over n plus 2. So if there were a finite number of terms, you would just plug in that n. If you knew there was going to be 10 terms, then you just plug in 10 for n. That would be the sum. There's an infinite number of terms, so we have to take the limit as these 2 go to infinity. Well, if we do that, what's going to happen? We get 1 over infinity, we get 1 over infinity. 1 over infinity tends to 0. And e to the 0 is 1. So each of these just become 1. In other words, we're left with e plus e to the 1/2 minus 2. And that's going to be the sum of our series. So again, just a quick recap. For telescoping series, the hallmarks that you should be looking for are you have a subtraction of 2 different things, and their only difference is that they've been shifted. How much they've been shifted tells you how many terms are going to be kept at both the beginning and the end of the sequence of, the series of terms. So our final answer here is going to be right there, e plus e to the 1/2 minus 2.